Hello. Welcome to Hardik Hyperion OS, which is a multi-threaded kernel with machine emulation on QEMU. So what is QEMU? It stands for Quick Emulator, which is a free and open source emulator. It basically emulates the machine's processor through dynamic binary translation and provides a set of different hardware and device models for a variety of guest operating systems. Now let me give you a brief overview of the code. This is the kernel.c file, and this is the main part of the code on which the kernel is built. It contains various functions for initializing the terminal, printing characters to the terminal, implementing backspace, so on and so forth. And these are all the header files required for the kernel to work properly, for the entire operating system to work properly. I'll just walk through this. So the print function here is responsible for inputting a string and displaying it on the output. The panic function here, what it does is, in case any part of the code an error is encountered, it just prints that error message and keeps the operating system running in an infinite while loop. This is the main kernel function where we first initialize the terminal, and then we see if the terminal was initialized properly by running these three print commands, the basically hello world prototype. And then we wait for a bit for the next set of inputs. So here we initialize the GDT, which is the global descriptor table. It's basically like a data structure that the operating system uses to store the addresses of various blocks of memory. And after setting up the various components like heap, file systems and disks, we again do a check with checking whether the file system, the FAT16 file system, was implemented properly or not. So we have a file called hello.txt, which contains the content. I am the text content of hello.txt. Now, if the read operation was successful, we display the contents of that hello.txt file in this part of the code. This part of the kernel.main function, it links to programs blank.c. It links to this process. So basically, first we are passing the argument testing, and second we are passing the argument abc. These two are two different processes. And then both of them execute the same function, which is printing the argument 50 times. You will see that how the context switch happens, and this basically proves that the kernel is a multi-threaded kernel. And this is the make file, which is basically a special file that contains rules for the binding of various codes and header files. So all the assembly C files and C files are compiled into object files and executive.exe files through the make file. Like the first line of make file contains all the object files to be generated. Build.sh is a file that exports certain required functionalities throughout each part of the program, and it also runs the command make all, which is executed right over here. This entire block of code is the make all command till here. Yeah. Config.h just contains all the constants which will be required by various parts of the program, such as heap requires the size of the bytes, each block size, address, table address, etc. The FAT16 file system requires the maximum number of files and descriptors, so on and so forth. Status.h just contains the error codes which can be encountered at any part of the program. Suppose invalid input output, invalid arguments, no memory, bad path, etc. Boot.asm is an assembly file which when the kernel is first run on the emulator, this is the code that boots the kernel on the emulator. It basically creates a bootable image of the FAT16 file system. String.c just contains various string manipulation functions that we can use, and these are pretty simple ones, like converting a character to lowercase, finding the length of a string, finding the length of a string up to a particular length, comparing string, copying strings, and converting to numeric digits, so on and so forth. So now let's take a step back from the code and talk about my experience with this course. I have learned a lot about computer system development throughout the journey of this course, ranging from understanding how to handle registers via assembly language, linking various header and C files together, and the most valuable skill of all, to debug the countless errors. What I felt is that this course perfectly encapsulates what it's like to build an operating system from scratch, how to synchronize various components, and fine-tune the various pieces of code. Additionally, I was exposed to various tools and techniques for developing and testing the operating system, and gained a lot of hands-on experience with kernel development, process management, and memory management via paging. Throughout the process of undertaking this course, I came to realize and value the hard work and effort that it takes to create a functional operating system, which many of us take for granted. It made me realize that we are standing on the shoulders of giants, and this is just the beginning of the path to greater knowledge. And from what I have learned, my advice to the people taking up this course would be to meticulously follow the course and install all the required prerequisite packages correctly, because a few minutes of undivided, pure attention can save you hours of debugging. Furthermore, you can actively participate in the Q&A discussion forums provided at the Udemy course, the bottom tabs, or you can also feel free to contact me at any time if there is a roadblock that you are stuck at. In conclusion, I would like to say that keep your thirst for knowledge alive and do the course wholeheartedly in order to truly absorb the essence of what is being taught. Happy coding!